So in this video, I'm taking this question which is based on mole concept. So let's begin the question. An unknown chlorohydrocarbon has 3.55% of chlorine. That means there is a compound which is chlorohydrocarbon and it is containing 3.55% of chlorine. If each molecule of the hydrocarbon has one chlorine atoms present in 1 gram of chlorohydrocarbon are. As we all know that whenever we say this much percent, so percentage is always calculated out of 100. So if it is given 3.55% of chlorine in the compound, that means 100 grams of the compound will be having 3.55 grams of chlorine. So what I can write? I am writing 100 grams of chlorofluorocarbon contains 3.55 grams of chlorine. So this is given as per the question. Now we are asked to calculate the chlorine atoms present in 1 gram of chlorohydrocarbon. So if 100 grams of chlorohydrocarbon is having this much chlorine, so 1 gram of chlorohydrocarbon will contain, it will contain 3.55 upon 100 grams of chlorine. Okay, now we are having the mass of chlorine which is equivalent to the 1 gram of chlorohydrocarbon. But we don't require the mass. In the question, we require the number of chlorine atoms. So as we all know that 35.5 grams of chlorine is equivalent to 1 mole of chlorine atom. This we know. 1 mole of chlorine atoms. The molar mass is always equal to 1 mole of chlorine atoms, which means Na atoms. Na chlorine atoms. So these atoms are present in 35.5 gram of chlorine. But we have to find out the number of chlorine atoms which are present in 1 gram of chlorohydrocarbon. So in 1 gram of chlorohydrocarbon, the chlorine present is this. So I can write that 3.55 upon 100 grams of chlorine will contain how many chlorine atoms? It will contain Na upon 35.5 into 3.55 divided by 100. So when I will solve, I will get the answer 6.022 into 10 raised to the power 20 atoms. So this is the final answer of this question. That means option 4 is correct. Okay, now let's move to the next question. So in this question, a sample of sodium chlorate NaClO3 is converted by heat to NaCl with a loss of 0.16 gram of oxygen. That means when NaClO3 is heated, it gives you NaCl along with oxygen. The residue is dissolved in water. Residue means whatever NaCl is obtained, that is dissolved in water. So when NaCl is dissolved in water, it will furnish chloride ions. And these chloride ions will help in precipitating the AgCl. The mass of AgCl obtained. So here we have to calculate the mass of AgCl, and mass of AgCl depends on the number of chloride ions furnished. That means whatever number of NaCl units are furnished, the same number of AgCl units will also be precipitated. So I can write this in the form of equation. NaClO3 upon heating, it gives you NaCl plus O2. 3 by 2 O2 I am doing so that I can balance the equation. Now you can see that when 3 by 2 O2 is formed, then 1 NaCl unit is formed. That means 3 by 2 O2 is equivalent to 1 NaCl unit, 1 unit of NaCl. Okay, 3 by O2 means how much grams of O2? That means 3 by 2. Now O2 is 32. That means it gives you 48. So 48 grams O2 is equivalent to 1 NaCl unit, and 1 NaCl unit will give you 1 mole of AgCl. Okay, so I can write that 48 grams of oxygen will give you 1 mole of AgCl. Okay, because 1 mole of NaCl means 1 mole of AgCl. Whatever number of chloride ions are generated, the same number of AgCl units will also be precipitated, because AgCl is being precipitated from chloride only. Okay, so 48 grams of oxygen is equivalent to 1 mole of AgCl. This is as per the equation, balance equation. Now, in the question it is given that when NaClO3 is heated, then it is losing the oxygen mass 0.16 gram. That means as per the given information, the oxygen which is formed, that is 0.16 grams. Okay, so when 48 grams of oxygen leads to 1 mole of AgCl, that means 0.16 grams of oxygen will lead to 1 upon 48 into 0.16 moles of AgCl. Okay, so when I solve, I will be getting 0.33 into 10 raised to the power minus 2 moles of AgCl. But in the question, I am not just asked to calculate the moles of AgCl. Rather, I am asked to calculate the mass of AgCl. Okay, so how you will convert the moles into mass? You will convert it by multiplying it with the molar mass. I hope you all know this, that when we multiply the molar mass with the moles, then we get the mass of the compound. So these moles I will convert into mass by multiplying it with the value 143.5. Okay, so when I will solve, I will be getting 0.478 grams. Okay, which is very close to 0.48. So the correct option of this question is option D. Option D is the correct option. I hope you have understood this question.